Hi, my name is Lee DeAnda, and today I'm going to talk about chain rule. Before I get started, I want to quickly review power function. Let's say we have f of x equals x to the fourth. Then the derivative using the power rule would be 4x cubed. And similarly, if we had a different function, let's say it's x squared plus 3x plus 4, then the derivative of g of x would be 2x plus 3, again using the power rule. Now, chain rule would come into play when we combine these two functions. Let's say we have the x squared plus 3x plus 4 raised to the fourth power. So using chain rule, we would do 4 times the inside function being raised to the third power, so it's like x to the fourth, and then times the derivative of the inside, which is the x squared plus 3x plus 4. So that derivative would be 2x plus 3. And so that's how we would use the chain rule to take the derivative of the composite function. Okay, let's try another one. Let's say your function is a square root of x. Then using the power rule, square root of x is equivalent to x to the 1/2. And so the derivative would be 1/2 x to the negative 1/2. And then let's say a separate function is x squared plus 5x. Its derivative separately would be 2x plus 5. Now let's say we have a composite function using both of these. Let's say our composite function is the square root of x squared plus 5x. And using chain rule, the derivative of the outside would be 1/2 times the same inside to the negative 1/2, and then times the derivative of the inside, which would be a 2x plus 5. Try another one. Let's try using e to the x this time, and the derivative for e to the x is itself, so e to the x. And let's look at a different function. Let's say x squared plus x, and its derivative would be 2x plus 1. Let's make a composite function using both of these. Let's say we have e raised to an x squared plus x. Its derivative then would be itself, so e to the x squared plus x, and then using chain rule times 2x plus 1. Using e to the x, let's say we have e to the square root of x. Its derivative would be itself, so 1/2 x to the negative 1/2. Okay, let's look at yet another function. Let's say we look at sine of x. The derivative for sine of x is cosine of x. And let's pair this up with the function x squared plus 8x, whose derivative would be 2x plus 8. So if I make a composite function here, let's say I have sine of the quantity x squared plus 8x. Then the derivative of this, so sine turns to cosine, so it's cosine, the same inside, and then chain rule times the derivative of the inside, which would be 2x plus 8. Okay, this time let's take a look with cosine. If you have cosine of x, its derivative is negative sine of x. With the function, let's say x squared plus 12x this time, its derivative would then be 2x plus 12. And if we were to combine these and make a composite function, cosine of x squared plus 12x, its derivative would be negative sine with the same inside times the derivative of the inside, so 2x plus 12. Okay, I hope that's enough to help you get started. We will definitely be doing more of this next time. Okay, that was just a quick introduction. We will be doing more chain rule next time.